Hi everyone. This is our look at chemical additivity. The first thing to say is that this is technically an application of Hess's law. It's going to be a very different method. The style of thinking that we're going to be doing is pretty different than other ways we can use Hess's law. However, it is a way to find delta H for a reaction. It's Hess's law in the end. What's unique about this kind of question is we're going to be provided with 2 or 3 or 4 other reactions and their delta H's. Let's look at our example, a little bit of foreshadowing. We're looking for the delta H for a balanced chemical reaction, and we're provided, this example has 2, but some other 2 or 3 or 4 other chemical reactions, they're balanced, and their delta H's are provided to us. What we're going to do is play around with these other equations so that we can find the delta H of our question reaction. There's always going to be some canceling if we have the same chemical on opposite sides of the arrow. They're going to be in different lines, but if we have the same chemical on opposite sides of the arrow, we'll cancel. That canceling could be complete or partial canceling. And another tool in our toolbox is we might be grouping terms. If we have the same chemical on the same side of the equation, we're going to group them together. Opposite sides cancel, the same side groups together. With the other equations that are provided to us, we're going to sometimes flip a reaction. The products become the reactants and vice versa. When we do that, the sign of the delta H is going to change as well. If it was a negative delta H and we flip the reaction, it becomes positive and vice versa. Sometimes we're going to also multiply or divide one of our provided reactions, and that's going to affect the coefficients. All of the balancing numbers would double, and the delta H would double as well, or they would all triple, or we could even multiply by like 2.5, we could even divide. In the end, we have to be left with the question equation. That means good news. We're always going to know if we're right. And the very last thing we're going to do is add all of those delta H's together to answer the problem. Here's an example. We have a formation reaction, carbon reacting with half an oxygen to make some carbon monoxide. We're being asked, what's the delta H for that reaction? We're looking for delta H. We have some other reactions given to us. We need to decide, what do I have to do to this reaction in order to turn it into the question? Okay? Here's the move. Find a chemical that corresponds to the question. Oh yeah, carbon dioxide is not in the question. Oh, but carbon is. Focus on one chemical in particular and then ask yourself, do I have the correct number? Is it on the correct side? This one, what we want is one carbon on the left-hand side. This reaction does have one carbon on the left-hand side. Everything matches. So our potential moves are flip the reaction or multiply and divide. Those two moves are not exclusive. We could flip and multiply, flip and divide. And it's important to also say that not doing anything is also an option. We want one carbon on the left. This first reaction does have one carbon on the left. So the move that we're going to do here is nothing. We're not going to do a move there. Now, it might feel redundant or it might feel like extra work, but I would very much encourage all of us to rewrite that equation, even though we're not going to do anything to it. Carbon I took my time to rewrite that equation. I'm confirming for myself that I'm not going to do anything to it. I'm not going to make a move. What about the second equation? What chemical can we focus on? Is there a chemical that corresponds to the question equation? Sure, the carbon monoxide. What do we want? We want one carbon monoxide on the right-hand side. What do we have? Two carbon monoxides on the left-hand side. The chemical that we are focused on is on the wrong side of the equation. So we're going to have to reverse this equation. Also, we want one, but we have two. It's on the wrong side and we have too many. So what's the move? Flip. We're going to flip this equation, reverse it, and divide by 2. Okay? When we do that, the sign of the delta H is going to switch because we're reversing the reaction. And if we divide by 2, all of the coefficients get divided by 2, and the delta H is going to get divided by 2 as well. This turns into carbon dioxide, carbon monoxide, the sign of my delta H here is going to switch. It was negative. Normally we don't write in a plus if it's positive, but here I want to be very careful. So I put my plus in there. The sign changed, and now I have to take 566 and divide it by 2. I take my time. 566 divided by 2. 283. Okay. Please notice all of the coefficients got divided by 2. Let me do it properly. A half. Just about missed that divided by 2. 2 carbon dioxides turned into 1 carbon dioxide. 2 carbon monoxides became 1 carbon monoxide. My 1 oxygen here divided by 2, I just about forgot, turned into half an oxygen. I reversed the reaction, flipped it, and divided by 2, so the sign of the delta H changed, and I divided by 2. At this point, we're going to think about canceling and maybe also some grouping. Chemicals on opposite sides of the arrow are going to cancel. Here's 1 carbon dioxide on the left, 1 carbon dioxide on the right. It's the same chemical on opposite sides of the arrow, balanced with the same coefficient. They're all going to cancel out. I feel good about that. I'm canceling out all of the carbon dioxides, and there's no carbon dioxide in my question, so that they're all getting removed makes me feel like I'm on the right track. Is there something else these two equations have in common? There is. Here's 1 full oxygen on the left-hand side, and then half an oxygen on the right-hand side. Half versus a full one. So this half gets canceled out completely, but then half of this 1 gets canceled, and that leaves a half behind. There's no other canceling in this particular question. It did not even include any grouping. Look for a future video about that one. I'm just taking my time to rewrite what's left. Carbon solid and half an O2 gas makes carbon monoxide gas. I just took my time. Again, I took my time. I rewrote all of the chemicals that didn't cancel out. And what was left behind was exactly the question equation. When we do our canceling and grouping, we must be left with the question equation. And good news, this one worked out. Okay? In the end, add the delta h's together. Really watch your signs when you're doing your adding. Okay? This one was, look at that, negative 393.5 plus positive 283. The answer here for the delta H is negative 110.5 kilojoules. Additivity, it actually represents a style of Hess's law question. It's very specific. We're only going to use this method to solve for delta H for a balanced chemical reaction. This question style really stands out because we're going to also be provided with 2 or 3 or 4 other chemical reactions and their delta H's. Then it's up to us to manipulate those other equations, flipping, reversing a reaction, multiplying or dividing a reaction, doing a bunch of canceling. This example did not include grouping, but we will see it in the future. We have to be left behind with the exact question equation. That means we're always going to know if we're right or if we still have some work to do. And our last step is to add those delta H's together to arrive at the answer. And I hope that helps.